We're now starting a new topic in 0005, which is permutations. So here's the definition of a permutation. A permutation of a set X is just a bijection from X to X. And in 0005, we're actually really only interested in permutations of particular sets. Namely, we're really going to care about permutations of sets of the form 1, 2, 3, 4, 5 up to n. And there is a special name for the set of all permutations of the set 1, 2, 3, 4, 5 up to n, which is Sn, or the symmetric group on n letters. So let's look at some examples of some permutations. I've written the definition of a bijection at the bottom of the screen here because, as the definition says, a permutation of a set is a bijection from that set to itself. So let's look at an example first of all, which is a permutation of any set at all. So first of all, the identity function, which you'll remember is the function which does nothing. The identity applied to an input little x is just the output little x again, is a permutation, perm for short, of any set X. Okay, next let's focus on examples which belong to the symmetric group Sn for some n. So we have a function f from 1, 2, 3 to 1, 2, 3 defined by f of 1 equals 3, f of 2 equals 2, and f of 3 equals 1. And you can see this really is a function from the set 1, 2, 3 to 1, 2, 3. It really is onto, because you can see that the whole of the set 1, 2, 3 is in the image of f, both, all of 1 and 2 and 3 are in the image of f. So it's onto, and it's also 1 to 1. So this thing genuinely is a bijection from 1, 2, 3 to 1, 2, 3. Therefore, it's a permutation of the set 1, 2, 3. And that means f is an element of S3, the symmetric group on 3 letters. And one more example, we're going to take the function g from 1, 2, 3, 4 to 1, 2, 3, 4. Defined by g of 1 is 2, g of 2 is 3, g of 3 is 4, and g of 4 is 1 again. Again, this really is a function from the set 1, 2, 3, 4 to the set 1, 2, 3, 4. It really is surjective because you can see that every single number, 1, 2, 3, 4, is in the image of g. And it really is 1 to 1, as you can check. So g is genuinely a permutation of the set 1, 2, 3, 4, which means it's an element of the symmetric group S4. So there are some examples of permutations. Let's now look at some ways to record permutations. So it was quite tedious for me to have to write out f of 1 equals blah, blah, blah every time to specify every single value that a permutation f takes. So for that reason we have a special kind of notation for elements of the symmetric group Sn called two-row notation. And the two-row notation for a function from the set 1, 2, 3 up to n to the set 1, 2, 3 up to n is, as I've written it here, we write two rows of numbers. On the top we write 1, 2, 3 up to n, and on the bottom, beneath 1, we write f of 1, beneath 2 we write f of 2, and so on. So let's look at some examples of functions and their two-row notations. So here is the function f from 1, 2, 3 to 1, 2, 3, defined by f of 1 is 1, f of 2 is 3, and f of 3 is 2. So the two-row notation for f would be, on the top, I write 1, 2, and 3. Beneath 1, I write f of 1, which is 1. Beneath 2, I write f of 2, which is 3. And beneath 3, I write f of 3, which is 2. We'll often identify functions with their two-row notation. So I will write f equals and then the two-row notation for f. So for another example, let's look at another function, this time called g, which is an element of S3. And this time, to write the two-row notation for g of 1 is equal to 2, so beneath 1 I have to write 2. G of 2 is equal to 3, so beneath 2 I have to write 3. And g of 3 is equal to 1, so beneath 3 I write 1. And that's the two-row notation for our permutation g. So before I stop here, let's just make one observation about two-row notations for permutations. So let's think about the two-row notation for a permutation of the set 1, 2, 3 up to n. So if f is in Sn, the bottom row of the two-row notation for f is just the numbers 1, 2, 3 up to n written in some order. And the reason that's true is that a permutation is in particular an onto function. And what's on the bottom row of the two-row notation is a list of the things in the image of f. So if f is onto, its image is all of 1, 2, 3 up to n. So that means all of those numbers must appear on the bottom row somewhere. And therefore, the bottom row of the two-row notation for a permutation of the set 1, 2, 3 up to n must be the numbers 1, 2, 3 up to n in some order. And you can see in our example here for the function f was a permutation of the set 1, 2, 3, and on the bottom row there you've got the numbers 1, 2 and 3 in a different order. And similarly here we have g, which is a permutation of the set 1, 2, 3, and again on the bottom row of its two-row notation you've got the numbers 1, 2 and 3 in some order. So that's an important thing to remember when you're thinking about two-row notation for permutations.